Good morning. It's a pleasure to be here today, and Brian, thank you for you at the Georgia Municipal Association for putting on this event in our fine city. Today, we're going to speak more about what's going on in Sandy Springs. I'm Joe Gillis. I'm one of the TSPLOST project managers in the city, and Langdon Sanders is GIS Team Lead for the city. And we're going to talk today about what we're currently doing in the area of smart cities and some things that we're looking to do in the future. We are both part of a task force that's been put together within the city of Sandy Springs. Several of our members are here today and supporting us. Thank you for that. I'm going to be focusing my part of the presentation on what's going on within Public Works, specifically in the Traffic Services Group. We have a traffic management center that's run by 3 staff that are in there during the work hours, and they're available off hours as needed. And I'm going to talk about 2 of the tools that they use to help manage traffic, not only real time, but also planning for the future, things that may be changed in the future for things we can do to improve traffic in our city. One of those is doing adaptive signals. We can call them smart signals. And to accomplish that, we purchased a system called SCOOT, which is a split cycle offset optimization technique. It comes from the United Kingdom. And we have that implemented currently on around 50 intersections, and we got about 50 to 55 more we're putting in the next little over a year. And so we have those on most of our major routes. Now, how does SCOOT work? Just at a high level, SCOOT is continually looking at traffic demand at intersections and looking for ways to optimize the signal timing or to get more cars through the intersection, trying to clear out the traffic, so to speak. These timing changes are small, and so they're not huge at one time, but they're just enough to gradually help improve traffic through. This is just a general map that shows where we have SCOOT deployed now. We started in 2008 planning the system. We got another 28 more online this year, and those are in the red area. The blue areas you see are ones that we've had for a few years. And then the green area are 2 separate projects that are currently in the process of construction and or design at this moment. And we hope to have those all in by the end of the year and into end of 2019 into early 2020 for the most recent system we started. Now, what does this employ in the field and in the TMC, so to speak? Within the traffic signal cabinets at each intersection that has SCOOT, you see there's a connection to detection. And the detection is typically what we use is what we call pucks, and they're about 4 inches square, and they're put embedded to the pavement. They're very fast to install, very easy to maintain. They're directional, they're magnetic, so you have to have them in the right direction. And those are what you see in the middle. They communicate back to the actual traffic signal cabinet controller. If they're very close, they can go directly, but typically the ones that are set back 400 feet or so, those have to communicate back through a radio communication mounted on a pole. Typically we have these breakaway fiberglass poles for safety reasons, and they're pretty easy to maintain. Our staff and our contractors can move those for us. And this is just a high-level map that kind of shows the different pieces and how they work together. That little red box represents a puck, even though it's really small actually. A puck in the pavement. Car goes over it, and it communicates back to the traffic signal control that there's a vehicle there. And SCOOT's able to determine how many vehicles are coming from all directions, and it's able to make those microscopic changes to try to help move traffic through the city. In parallel with that, we have another tool that actually augments SCOOT to some extent. We are in the process of getting this up and running again. We have it in some intersections, but we have more we're adding in the future. It's the BlueTOAD technology from TrafficCast, and this is it's basically a wireless data collection system that takes advantage of the Bluetooth that you're running on your cell phones while you're driving down the road. What this is doing is it's anonymously determining how fast vehicles are moving across our street network. It's able to detect at point A to point B. It knows how far apart they are, and how many seconds it takes. It knows, okay, an anonymous vehicle is going that fast. Well, our TMC staff is able to look at that data and determine, okay, well, this is normal, this is abnormal. There may be an alert to say, hey, we need to go out and see what's going on, maybe turn over our traffic cameras onto that and see what's going on. And this just kind of shows what I just said a little bit, showing if you got two separate BlueTOAD detectors out on the street, and then you show the area where a car might go through, and it communicates back to the controller, and ultimately back to the TMC to know what's going on. Now, as for long term, you can record traffic signal times over a period of time and say, well, hey, how's Scoot working? If we have BlueTOAD put it in where Scoot also, we can say, okay, well, Scoot's working, or maybe Scoot's not working. We need to make a tweak to something, and you can do that. So we are definitely doing it for that purpose. We'll talk about a couple other things before I pass off to Langdon here. We're working on some different public safety, public works collaborations. I'm in the public works group, and we have some here from public safety, and we're definitely interested in making sure that whatever we do for one organization helps each other. We have a set of traffic cameras that we have on our street network, particularly where we have communication to those is where we have those. We're also we have some cameras in areas that are not necessarily intersections, but also for just neighborhood safety cameras. And we're looking at deploying more cameras around the city, HD quality, and to not only to help with traffic, but also anything we can do for crime investigation, anything safety related that we can use for that. And we also are looking, we haven't done this yet, we're looking into license plate readers at our gateway locations across the city, and being able to say, okay, can we help with any kind of investigations? But another big thing from the traffic point of view that I'm part of, we can do some really good traffic studies with this license plate readers to know how's traffic coming into our community, where are they going, and particularly for AM and PM peaks during commute times, that it really can help our traffic department know how to further improve and deploy systems in our city. I'm going to go ahead and ask Langdon to continue with Dr. McDonald's.
Thank you, Joe. So I'm going to show you how your spatial technology can improve your services. There's a long word for that called geographic information systems. Dom was very great about showing us that that's much more than a map. In fact, your GIS team can do a lot of things, and they can help you with pretty much any facility where you're doing services with the city. The technology is there to assist, again, with almost every aspect of local government. First, we're going to look at how GIS is being used right now to support response for the Camp Fire in Paradise, California, how drone technology can take these maps even further with rapid response aerial imagery, how informing your community is a tenet of good government and saves you time and improves your internal services, and how web applications can be used to create self-service tools for common requests, and how private partnerships allow you to engage with citizens on platforms that they already use. So let's look at the Camp Fire. This is Paradise, California. More specifically, this is 7641 Skyway Road, Unit B. Current records show 3 firefighter injuries and 85 civilian fatalities as of last night have occurred from this fire. There are total structures of 13,972 residences, 528 commercial, and 4,293 other buildings have been destroyed by this fire. Where did I get that number? And where did I get this picture? Butte County, California has created this public information map using the same exact GIS technology that we use here at the city, that Dom showed us earlier, and that I know Nick uses at Johns Creek. It's a way to take your information from the field, store it in a database, and make it usable for people at your city, but then also so people are responding to the event, and then also the public. Emergency managers, they can view the situation in its entirety and at the neighborhood level and block to block, and they can also zoom out to see the greater picture. Behind each of these points is data. There's information on who collected it and when, the condition of the structure, and you can also attach pictures and do all kinds of other great stuff. This is Paradise, California. Web applications and maps are just the beginning. UAV or drone technology is no longer a dream. It's real and is being used by governments both big and small today. This is flyover video, also from the campfire. Closer to home, the city of Tucker has started its own drone program, and beginning with aerial imagery and making 3D models of their parks. Here at Sandy Springs, we have 2 drones on site. We have pilots in training, and we're working on formulating a drone program for 2019. The applications of UAVs are expanding exponentially, and the technology is here. You won't even be the first one to get going. So there's lots of great policies and templates you can already start using. We use spatial technology to inform our community. This consists both of internal staff and internal communities, but also the public and partner agencies. Here's how we use spatial technologies in our own emergency response at Sandy Springs. During major storm events, bad things happen. Namely, trees fall on things and roads become impassable from trees, ice, a combination of both. Sometimes a gas leak can shut down a major intersection. To effectively manage these events, our Emergency Operations Center must be able to understand both the ground view, which is what you see here, and the greater context across the city. Within the Emergency Operations Center, we dispatch police, fire, and public works teams to respond to that event. But also our communications team is informing the public and our elected officials using information provided by those field workers. Staff are mapping these events, putting them into our databases, and it's all happening continuously with all these different inputs. Our GIS team maintains our incident application and performs analysis on the fly, such as number of homes that were currently blocked from emergency services. This happened during Hurricane Irma. We had 2 sides of a neighborhood were blocked by trees. We wanted to know how many homes were affected and prioritize clearing at least one of those entryways. We also share our data, the same information being used by emergency services with consideration to cybersecurity. We don't share everything, but what we can share that's not sensitive. The same information that we're using is also accessible to the public and the media. Citizens can understand what's happening in the neighborhood and, again, what's going on around the city. But also the media can have accurate information and report users through TV, radio, and these other platforms that they're using. We are proactive about providing all kinds of information and ways to understand our community. The GIS team has created an open data and application portal, just like East Point, and Johns Creek I know has one as well. This provides free and transparent access to many of the same data sets used by internal staff. It saves time from data records and open records requests, data requests and open records requests, and engages the public. And many staff use those same apps as well. Here's just a few of those. Popular applications that we have include our data tile downloader. So we have partner contractors that need aerial imagery and contours. We just send them the link and they can get the data themselves. We have applications to track utility permits. So you can zoom into your neighborhood and see who's working on your street. Are they in fact permitted, and contact information there that's updated nightly with automated processes. We also have an apartment safety app in collaboration with our police department and crime analysts there, which aggregates the crime data to those communities as well. Most importantly, a smart government is an engaged government. We must provide information to our community where they are. We cannot expect the average user to come to our websites and view our resources through your typical browser. One example is our partnership with Waze, the navigation app. In short, we provide them with authoritative road closures and incident information, and then in return, they give us data on user reports and traffic jams. So let's take a look at that in a case of our engagement with the citizens through live incident management. Here's an example where a semi-truck took out a utility pole on Roswell Road, this major thoroughfare right here. The communications team first used social media platforms to quickly spread the word, and shortly thereafter our text message alert system was activated because it was a major event. The GIS team was alerted about the closure at the same time as other staff through our traffic notice email list. We also subscribe to the Twitter feed too, just so we get those push notifications. We added the closure in our maps, which feeds into Waze. You can use your own map platform, or you can also enter it right in theirs. This closure was fed directly into Waze and was used in their navigation algorithms. Within 15 minutes, the closure also showed up on Google, which coincidentally owns Waze. We have successfully provided a service to our community on apps that they were already using. They didn't even realize that they were getting a benefit from our technology and our work, but they didn't have to come to us for that same service. This is the future of government, and with the help of spatial technology and smart cities initiatives. Thank you.